Assalamualaikum warahmatullahi wabarakatuh. Today we will present about the 5G wireless communication. Before that, we will introduce self. First is my name is Muhammad Faizi bin Ramli.
My name is Nona Suhamita Azman.
Is Nur Adana binti Mazuki.
And my name is Nuri Iza Izati binti Rahmat Zanti. Okay, introduction. 5G is the latest generation of cellular technology. It aims to deliver faster, more relevant connection than previous generation. The main feature of 5G are higher speed, lower latence, and the ability to support massive device simulation and energy saving. 5G has high speed for data transmission because according to the communication basic, short frequency and large bandwidth. With 5G data, sent over wireless breadboard connection can travel at multi-gigabit speed, which is 20 gigabits per second. Okay, next.
So next is general history. The first commercial automated cellular network is 1G, was introduced in 1918. 1G pioneered voice service using advanced mobile phone service AMPS technology, utilizing FDMA for wireless transmission with channel capacity of 30 kHz and the frequency band which is 824 to 894 megahertz. So next is 2G. Was launched in 1919, offer digital incrementation, increased spectrum efficiency, and data service like SMS, image, and multimedia messaging, enhance mobile phone penetration. And the frequency band for 2G is 850 to 1900 megahertz. Next for 3G, in 2000, 3G service offer high-speed mobile access, IP-based service, multimedia, email, and video conferencing. It offer high data rate, channel carrier width, and the high spectral efficiency. And the frequency band is 1.8 to 2.5 gigahertz. Next for 4G, which is in 2010. 4G system offer mobile broadband internet access to device which is with wireless modem with application including enhanced web access, IP telephony, gaming, and cloud computing. The frequency band for 4G is 2 to 8 gigahertz. So lastly for 5G in 2020, the fifth generation of wireless mobile broadband technology offer faster speed, lower latency, and power saving, adapting to modern technology challenge and creating true wireless network like the worldwide wireless web. And the frequency for 5G is 30 to 300 gigahertz. Next.
Okay, for problem statement, 5G communication has some challenge that cannot be solved, which is, okay, first, provision of large information capacity. So how to provide large information capacity by considering price, size, and efficient in the internet. The 5G main base station over a wide area with various place. The second is special internet channel for basic internet. Security in 5G will be a difficult issue because internet channel are allocated for basic internet channel. However, they are used for various applications. So connectivity is very important among application and the internet to integrate user and device. And then lastly is 5G wireless communication speed. 5G download speed can currently reach more than 1 megabit per second or even up to 2.1 gigabit per second. Okay, for example, downloading an apps or an episode of a Netflix show, which is currently may take up to several minutes, but it can be complete in a second.
For basic principle, the basic principle of 5G, first is use high frequency and spectrum. 5G technology utilize high frequency band, including millimeter wave, to enhance data transfer, but also have limitation in range and optical penetration. Next, increase data rate and speed. 5G aim to provide significant high data rate than 4G, enable faster download, smoother streamer, and reduce latency. Next, number 3 is low latency. Latency refer to take time it takes for data to be transmitted from the sender to the receiver. 5G technology aim for ultra low latency potential in order of millisecond. Next is massive MIMO, multiply input, multiply output. 5G technology significant impact advanced antenna technology like massive MIMO system, enhancing data through and spectral efficiency. Next is network slicing. Network slicing is a technique that divides a network into multiple virtual networks. Is tailored to specific needs like IoT, mobile broadband, or business critical service. And lastly, beamforming and smart antenna. 5G utilize beamforming to enhance the signal transmission direction, while smart antenna dynamically adjust their radiation pattern to enhance user and device service. Next.
Technique used in 5G communication, I give some example. Unification of speech recognition technology in the user interface will ease the use of the application for each user. Next. In advantage and disadvantage. For advantage in the 5G communication, the first one is provide a unified global standard. Second, provide common service independent of their capability. Third, better network coverage. Fourth, provide higher bandwidth. And lastly, more effective and efficient. For disadvantage in the 5G communication, obstruction can impact connectivity. Second, initial cost for rollout are high. And lastly, upload speed don't match download speed. Next. In area of application, it has a four used in the 5G communication, high-speed mobile network. Third, second, Internet of Things. Three, healthcare and mission critical. And lastly, satellite internet.
All right. Next is the result and discussion. First of all, this result, we find that using the different model, uh, which is the device. So first, we get the result from how rainfall. Okay, how rainfall. If the condition in rainfall, how the frequency about the 5G signal go through. Okay. So in this graph, these two graph is the same, but just change the from meter and next the by the kilometer. So if can see the purple color is the too high. Okay, go high because this is a 100 gigahertz. So this is quite high signal. So the starting decibel dB is from 3 and go for 1000 meter, we will go higher. Okay. So the next the gigahertz will decrease slightly. So the black, yellow, green, and lastly the green. Okay, the green is 10 gigahertz, so it's a very low signal. This is a for in condition rainfall. Okay. So next about the LOS possibility. LOS is the line of sight, which is a test in indoor and the outdoor region. Okay. So first graph is indoor region. So in the red is using ITUR model device. Blue is A1 model and green is A2 model. Okay. Take using a three device to test is accurate or not, where the device is more accurate. So uh, two device A1 and A2 model is same because device is maybe a same construct model. So this line is slightly same. The three line is same. So like outside indoor region, a path 0 to 25 meter. Next is outdoor. Okay, this is outdoor region. In outdoor region, use different model. Indoor we use ITUR model. If indoor we use this 3GPP model. Okay, the line is from higher for and to go to decrease. Okay. Next is loss LOS line of sight probability for the urban and highway. Okay, urban is like a city. Okay, test in around city building. Okay, so the line is for red low density, blue is medium density, and green is high density. Okay, so starting all is the line density from 0.9 decrease until after the uh, uh distance go increase. Okay, go far. Next is highway result starting one. Okay, one after the meter increase, the line will go down, go decrease. This data using the that's device, another device. Okay, this is the path flow estimate, okay, for LOS and NLOS. LOS is line of sight and NOS is non-line of sight. Okay. This is all from result combined together. Okay. The if LOS, you can see the line blue is the highway scenario is the high quite, and the red urban scenario which rain attrition, which the heavy rain. Without heavy rain, we go lower. Okay, is the non-line side is the same line go through. Okay. Okay, so first is overall system performance. So this is figure 11 is LOS and NOS link margin bar graph representation for the urban and highway scenario, which and without rain attrition. So the red is urban scenario without rain. Okay, the purple is rain attrition. Green highway without rain. Blue is highway with rain. Uh, Cyan is the scenario without rain, and yellow is urban or highway with rain. So as you can see, the distance are very less, so the band is higher. Okay, if the distance go so far, the dB is will decrease. Okay, decrease slightly. And the very negative dB is urban highway scenario, which heavy rain. So they go the dB uh, negative. So the conclusion, we estimate the rainfall attenuation, Pavlov's lane margin, line of sight, okay, and the non-line of sight probability using indoor and outdoor probability model. Next, the study estimate and compare the optimal path difference between urban and highway scenario. Third, the result indicate that the urban scenario without rainfall has a higher optimal distance. Next is we also estimate path loop and limb margin, considering indoor line of sight probability model, which we apply to location with compatibility weather. And the last is incorporating indoor non-line of sight probability model to estimate path flows, link margin, and optimal path difference in a small indoor region called expand the study of future research. So, and last is this. This is a reference that we combine and do the research about the 5G communication. Okay, we put the seven literature review. Okay, that's for all from we this group. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.